Hello, welcome to the video series for exponent rules. In the first series of 3 parts, we're going to learn the product rule, and in part 1 we're going to look at rewriting negative powers. It says rewrite the expression without using a negative exponent. Well, when we have a negative exponent, there's a rule for this that says for any a to the negative n power, a to any negative numbered power, equals 1 over a to the n. And we need to think of negative powers as the process of repeated division. When we think of them as repeated division, if I could spell division, we remember that we are dividing right here. So the 1 over is our division aspect, and the repeated is the exponent. So, similarly, if I have 1 over a to the negative n, I can't have a negative in the denominator because it tells me, because of my rule, 1 to the negative, a to the negative n is 1 over a to the n. So similarly, 1 over a to the negative n takes us back to a to the n. When you divide by fractions, you end up multiplying by its inverse. So let's look at the example here. It says 1 over 2 to the y to the negative 4th power. So we need to look at this as 1 over 2 times y to the negative 4 so we can separate my values. Using my rule here, my a to the negative n is the y to the negative 4. So this is the part that I'm switching. And my answer is going to be 1/2. So I'm going to keep the 1 over 2, and I'm going to flip the y in the 4th power to make it a positive integer. So it turns positive and it goes to the top. So now I have 1/2 y to the 4th power, which can combine to y to the 4th power over 2. And that will be our solution. Let's go look at a few more examples for applying this rule. Here we have 3 more problems. Let's label these A, B, and C so we know what we're referencing in the future. So we have A, B, and C. It says rewrite the expression without using a negative exponent. So I need to look at negative 3, and we'll just rewrite it. Negative 3 z to the negative 4th power. Again, we need to think of this as 3 times z to the negative 4th so that we separate our integers, we separate our bases. And this z to the negative 4th is my a to the negative n. So this is what I'm going to be separating. So I'm going to rewrite it as negative 3 times 1 over z to the 4th power so that I have my positive 4, which simplifies to negative 3 z to the 4. And a common mistake that we make, let me rewrite this, z to the 4. A common mistake we make is that the negative base is what changes it. It's not. It's the negative exponent. The base stays the same. The base stays. Let's look at letter B. It says 1 over 6m to the negative 5. Well, we need to think of this as 1 over 6 times m to the negative 5 so that we separate our a to the negative n. And this 1 m to the negative 5th is what I'm separating. So let's rewrite it down here. 1 over 6 m to the negative 5. So to rewrite this, I'm going to write it as 1 over 6 times m to the 5th power, and when I multiply this, it's going to treat it like it's m over 1, and that's going to equal m to the 5th power over 6. I'm not writing my powers very well today. M to the 6th power over 6. Go ahead and try letter C on your own, and we'll check the answer after we're done. Alright, this letter C says 4y to the negative 5th. So I'm going to separate these so that my y to the 5th is my a to the negative n, I'm going to rewrite it as 4 times 1 over y to the 5th because I need the positive exponent. And then when I multiply them together, my simplified form is 4 over y to the 5th power. Remember just to flip only what has the negative exponent. All right, let's go on.